Annenberg Media.
Hello, I'm Teresa, and today we'll be exploring these three topics. Performing inference on proportions using a new kind of z-statistic. Calculating confidence intervals and significance tests using proportions. Comparing proportions from two different populations. Let's say we wanted to calculate the nation's unemployment rate.
Louis is just one of the millions of Americans going to work in the morning, but he's not just any other worker. He's the Commissioner of Labor Statistics.
It's very important to be precise in calculating the unemployment rate because it is such an important statistic. It tells us how our economy is doing and how different parts of our nations are doing.
Louis conducts surveys to see where unemployment stands in our nation.
So what is your name? How many hours did you work last week? What's your favorite color?
What's your favorite color?
Now we will compute a confidence interval for unemployment. Let's say we took a sample of 2,000 people, of which 140 were unemployed. This gives us a sample unemployment rate of 0.07. This is our p-hat value. We will use binomial distribution, which is close to normal when n is large. The mean of the distribution is p, and the standard deviation is the square root of p times 1 minus p over n. Because we don't know p, we will replace it with p-hat, which is a good estimator when n is large. The formula for calculating a confidence interval is p-hat plus or minus z star times the standard deviation. After plugging in the values, we see that our confidence interval equals 7% plus or minus 1.1%. You can see that figuring a confidence interval around a proportion is just a slight twist on what we already know. The same holds true for significance tests. Let's say that the last census says that 10% of the population is unemployed. 5 years later, we survey a town with 55 out of 500 people unemployed. Is this proof that the unemployment rate has changed? The null hypothesis says that nothing but natural sampling variation is at work, while the one-sided alternative hypothesis claims that the unemployment rate has increased. Now we can adapt our z-statistic formula for standardizing. After solving for z, we get 0.75 with a p-value of 0.23. In other words, there's a 23% chance of achieving an unemployment rate of 11% in our sample just because of natural sampling variation. This is pretty high, so we have no reason to reject the null hypothesis.
Cupertino has a serious water contamination problem, and we can't even drink the water here.
So in East Cupertino, our water is contaminated because we get it from memorial reservoirs. But on the other hand, in West Cupertino, the water is clean because we get it from some other different source.
My friend Louis is very sick because of contaminated water. I brought this issue to the water companies, but they won't listen to me. What am I supposed to do? Just let Louis die?
We examined the rates of birth defects where contaminated water was used, East Cupertino, and where contaminated water was not used, West Cupertino. In East Cupertino, there were 16 birth defects out of 414 total births, and in West Cupertino, there were 3 birth defects out of 228 total births. Therefore, p-hat1 is 3.9% and p-hat2 is 1.3%. This leaves us with an estimated difference of 3.9% minus 1.3%, or 2.6%. Before we compute a confidence interval for the difference between the two samples, we observe that the distribution of the difference between two normal samples is in itself normal. The mean of this distribution is p1 minus p2, and the standard deviation is the expression below, which is basically a combination of the two standard deviations. After replacing p1 with p-hat1 and p2 with p-hat2, we can solve for the confidence interval. p-hat1 minus p-hat2 plus or minus z star times our new standard deviation. Z star for a 95% confidence interval is 1.96. After plugging in the rest of the values, we get 0.039 minus 0.013 plus or minus 1.96 times the standard deviation, which comes out to 0.012. This leaves us with a confidence interval of 0.026 plus or minus 0.024. The interval may seem hard to interpret as the rate of birth defects could be as low as 0.2% and as high as 5%. But the interval lies entirely above zero, which means it's highly unlikely that the contaminated water has no effect. Therefore, we can conclude that there is a significant difference between the rate of birth defects in East and West Cupertino.
In the famous Cupertino witch trials, people were tried for witchcraft based on pure suspicion alone. People were afraid to leave their homes at the risk of being accused of witchcraft.
I've been a witch expert for years, but I've got to say, tracking down those witches has been frustrating.
They're not easy to spot, but after being in this line of work for so long, I've developed a knack for it.
I can smell them. Being a witch, you know, it has its perks. Like fly, that son of a witch.
We'll work through a two-proportion significance test using the rates of conviction between men and women in the Cupertino witch trials. From our data, we see that of the 20 men accused, 2 were convicted, giving us a p-1 value of 0.1. For women, 14 of 68 accused were convicted of witchcraft, giving us a p-2 value of 0.21. This seems like a significant difference, but let's use a significance test to see if it really is. Our null hypothesis is that the two rates are equal, and our alternative hypothesis is that they are not. The alternative hypothesis is two-sided because P1 could be either greater than or less than P2. We will pool our two samples to find P, the conviction rate of men and women. This approximation comes out to 0.18, our p-hat. Our significance test is p-1 minus p-2 over our pooled standard deviation, which comes out to 0.098. This yields a p-value of 0.26, which is much too high to reject the null hypothesis.
In this program, we learned about inference on proportions and which tests to use. Until next time, I'm Teresa. Thanks for watching.